Okay, guys. So with this phosphate note sheet, some of the things that's kind of important to understand. If you watch the video, the crash course video, he gets into the phosphorus cycle, very similar to the nitrogen cycle, except for this is the only cycle where it's not part of atmospheric gases. Okay, so the phosphate cycle all is basically either aquatic or in the ground. So how does this enter our aquatic ecosystems? So as water runs across these rocks, we've talked about a little bit of acid rain, breaking down some of these minerals, and that's kind of the original source of the phosphate. Okay, then as that enters the water, phosphate is a key component. It's usually what they call the limiting reactant in plant growth. So we can have an abundance of nitrogen, we can have abundance of water, sunlight, all these things. But if we don't have this phosphate or phosphorus, that's going to limit plant growth. So this can be kind of a big thing that really triggers these algae blooms as well. And again, we can see one of the big new contributors to phosphate, our phosphates in our water system are fertilizers. So we also see it in animal waste. So as things consume plant life, phosphates, I mean, they are very important because when we talk about our DNA, we have a main phosphate group on there, ATP, the P in phosphate, or the P stands for phosphate. So we have three of those. So it's super important for all living organisms. And as we die basically, and as decomposers break down their bodies, that phosphate gets released back into these ecosystems, but is quickly taken up by plants again. So what we look for is a balanced system. We're going to have zero point 0.1 parts per million or less for phosphate. Anything over 0.025 parts per million, we're going to start to see plant growth and increased algal growth. So yeah,